remember, in Chapter 23, we learned about the Milky Way galaxy, our galaxy, which is a spiral galaxy. Now we're going to learn about other galaxies out there in the universe, which, by the way, there are billions, hundreds and hundreds of billions of other galaxies. Of course, we haven't counted them all. It's just statistically, when we look out into the universe, there is just a tremendous amount of galaxies. All right, this object, which kind of looks a little like a star, is actually a galaxy. Notice it. This is something that what I'm pointing at right here is a feature of some galaxies. There's actually material flying out of the galaxy. A jet of material, and sometimes we can see that. All right, so this is the what we're generally going to talk about. Hubble's classification scheme, the distribution of galaxies in space, what's known as Hubble's law. So Hubble, of course, was an actual astronomer who lived, did a lot of his work in the 1920s, and very significant work. All right, we'll discuss what's called active galaxies after that. We'll look at these relativistic redshifts, and then we'll figure out try to figure out what the central engine of an active galaxy is, and what's the difference between an active galaxy and, of course, a normal galaxy. I mean, as you could probably guess just by the name. It has to do with the amount of energy that's coming off. All right, so let's get into Hubble's classification scheme. This is actually a really interesting picture. This is called Abel's cluster, and this is just a particular region of the sky. It's well known because almost every object you're looking at is actually a galaxy. So remember, let's discuss again what galaxies are. They are huge collections of stars that are gravitationally bound to each other. That's important to understand that they're gravitationally bound to each other. All right. So Hubble, of course, and let me go into a little bit of the history. Hubble was the first one to use the Mount Wilson Observatory. This is an observatory that is north of Los Angeles. Unfortunately, it can't really be used very much anymore because it can be used, but not for significant astronomy, because the lights of Los Angeles have just basically made it almost completely useless. Anyhow, this was like the best telescope in the world, and in the 1920s, Edwin Hubble was using this particular telescope and made some very significant discoveries, as we're going to see. And just to let you know, the kind of, especially when we get to Hubble's law, in modern times, somebody makes that kind of a discovery, he would have won a Nobel Prize in that. Anyhow, all right. So let's you'll understand why I say that in a little bit. So spiral galaxies. What spiral galaxies? He actually classified these things, and what we're looking at basically on the size of the central bulge, right? So if a very large central bulge, it's actually two things. It's the size of the central bulge, and it's also how tightly the spiral arms are wound. So if the size is really large, it's called an SA. If it's kind of medium size, it's an SB. But notice the the spiral arms are a little bit looser bound. See, these are tightly bound. These are a little bit looser, and this one is the small. Although it doesn't really look like this in this picture, this is the smallest central bulge, and that would be, of course, an SC. And the spiral arms are the most loosely bound here. All right, very nice. So let's go on. Oh, I guess they're just talking about that. So we get SA has the largest central bulge, SB, which is kind of medium size, and then SC is the smallest. The thing about this is that this scheme is somewhat, it's not something that is basically something that Hubble looked at these particular galaxies and just labeled them from just looking at them basically, which is fine, as a starting point. Just keep that in mind. It's a fine starting point. It's not certainly the most important. So we'll just leave it at that. It's a good starting point. All right. So again, SAs have the most tightly bound. I already said all this. SBs are a little looser, and then SCs are less. Of course, this because they're spiral galaxies, they have a disk, they have a central bulge, and they have a halo. The core, they're talking about, where the supermassive black hole exists, and of course, the disk, and the disk is where the spiral arms are. If you're looking at a galaxy kind of edge on, sometimes you don't actually see the spiral arms as we're going to, as some of the pictures will show. In fact, here's one right here. That's kind of nice. And I kind of like this galaxy. There's different ones. People have favorites. Again, there are billions and billions of galaxies. This one is particularly bright. It's with even just a moderate sized telescope, you can see this particular galaxy. So it's called the Sombrero Galaxy. It's kind of obvious why it's called that. It has this region of relatively dark material. This is, gas and dust that is seen kind of edge on. And there's, of course, you can see the central bulge. There are many halo objects. But you really can't see the spiral arms with this particular one. And this this Sombrero Galaxy, Hubble classified as an SA, right? Because it has the largest. It has a very large central bulge. All right, very nice. So, and then it turns out that there are other types of spiral galaxies, and we kind of suggested this in the last chapter, in chapter 23, because in fact the Milky Way is a barred spiral. All right, so here's an extreme example of a barred spiral. You see this huge bar of material, and of course the larger that central bulge is, so you basically would call these SB, and so the largest one, the barred spiral SB, and the largest one would be A, so SBA. So it's like capital S, capital B, and then lowercase a for the largest one, and then the medium-sized one would be capital S, capital B, and then lowercase b, and then of course the one that has the smallest bulge, or smallest bar and bulge, of course, would be a C. And of course, it also it also goes with the amount of winding or the tightness of the winding. So the very large bulge has the tightest spiral arms that are wound, and then it gets looser, and then even looser here. The SBC has the loosest ones of all. All right, and again, they don't all look exactly like this. And again, it's a little bit in the eye of the beholder, if you will. All right, so now we get to we have just regular spirals, barred spirals, and then now this is an entirely different type of galaxy. These are called elliptical galaxies. There is absolutely no spiral arms at all, no disk. They kind of look they're like big football-shaped things. Some of them are a little wider than others, and they come in a huge variety. For example, there are some ellipticals. These are like super giant ellipticals that are literally have trillions of stars. Keep in mind, like our Milky Way has, anywhere from about 100 billion to 200 billion stars. So one of these giant ellipticals, and truly, these things are truly giant. Some of them, they have trillions of stars. And then there's these little dwarf ellipticals that contain, maybe about 1 million stars or even less than that. So here's one of the. We'll look at some pictures of ellipticals in just a second. But here's one of the key features of elliptical galaxies. There is basically almost no gas and dust in the elliptical galaxies. I mean, it's just all the gas and dust has already been taken up in star formation. So there's basically no new star formation at all in elliptical galaxies. Okay, so they tend to be redder in color, right? Because they tend to be very old. And you do see, with some elliptical galaxies, you do see this hot gas that is the jets of material that is coming from the elliptical galaxies. Although that's not, we'll see why that is a little bit. All right, and it's not all of them; it's just some. All right, so here's some pictures of ellipticals, and of course Hubble, being the person, remember, he classified the spiral galaxies as SA, SB, SC, he did the same kind of thing with, slightly different for ellipticals. So with elliptical galaxies, he went from, so they're classified as E. Capital E is an elliptical galaxy. And so it ranges from E0, which is the most spherical, So this is be an example of it. This is an E1, so it's almost the same as an E0. And then as it gets more and more football shaped, more elliptical, like the most elliptical ones are called E7. Right? So like this one's an E5, for example. Again, it's more in the eye of the beholder. It's kind of, it's not, it's more subjective than it is. Although, Hubble spent a lot of time looking at these things. All right. And so this, we'll talk a lot more about elliptical galaxies and what exactly is going on in elliptical galaxies. All right, and so here's another one that was kind of a weird thing that it basically showed no spiral arms, but it wasn't classified as an elliptical. So this is what he called the lenticular galaxy, because it basically looked like a lens. And of course there's the just the regular, the S0, and then there's the barred one, which is the SB0. All right, so those are